All right, let's talk about AWS CodeBuild. If you've ever just wished you could push your code and have it all automatically compiled, tested, and packaged up in the cloud without ever having to think about a server, then this is the service for you. Today, we're going to crack this thing wide open and see exactly how it ticks. Let's get into it. So here's our game plan. We're going to start with the big picture. What is CodeBuild, really? Then we'll zoom right into its core, a file called buildspec.yaml, and see how it pulls all the strings. After that, we'll dive even deeper into that file's structure, before finally looking at how you can use CodeBuild to reach into your private network. So, first things first, what exactly is this thing? What problem is CodeBuild trying to solve for us developers and DevOps folks? Okay, at its core, AWS CodeBuild is a fully managed build service. And those two words, fully managed, are everything. It means you can stop worrying about patching build servers. You can stop worrying about what happens when 5 different people try to build at the same time. You just point CodeBuild at your code, and it takes care of the whole shebang, compiling, running your tests, and spitting out a software package that's ready to go. And this is where you start to see just how flexible it is. Over on the left, you can see it'll pull code from pretty much anywhere. AWS's own services like CodeCommit or S3, or popular ones like GitHub and Bitbucket. And on the right, you've got all these built-in environments for languages like Java, Python, and Node.js. But honestly, the real magic is this Docker icon at the bottom. If your language or specific setup isn't on the list, no problem. You just bring your own custom Docker image, making CodeBuild pretty much infinitely extendable. Okay, let's move on to the single most important piece of any CodeBuild project. And I'm serious here. If you're studying for a certification or you just want to get how this service works, the next couple of minutes are absolutely crucial. So let me ask you a question. If you had to point to the one file that acts as the brain for the entire operation, what would it be? You got it. It's the buildspec.yaml file. This is the blueprint. It's the instruction manual that tells CodeBuild exactly what to do with your code, step by step. Now, this slide lays out the two non-negotiable rules. The file has to be named buildspec.yaml, and it has to be sitting at the very top level, the root of your code repository. So why so strict? Well, think about it. CodeBuild is all about automation. It doesn't guess. It looks for that one specific file in that one specific place to get its marching orders. If you get either of those wrong, your build is going to fail before it even starts. Okay, so we know CodeBuild needs its instructions from the buildspec.yaml. But what does the whole process actually look like from start to finish? Let's walk through the life of a typical build. It all kicks off when CodeBuild fetches your source code, and of course it grabs that all-important buildspec.yaml file along with it. Next, it spins up a completely fresh, clean container using a Docker image. Then it just starts executing the commands from your buildspec file one by one. And while all this is going on, it's streaming logs out so you can see what's happening. Finally, assuming everything went well, it takes the output, your compiled app, your zipped up package, whatever it is, we call that the artifact, and it uploads it to an S3 bucket for you. And this logging, it's about so much more than just seeing if a build passed or failed. With CloudWatch logs, you can dig in and debug issues as they happen. With metrics, you can track how long your builds are taking and spot problems. And with Amazon EventBridge, you can do cool stuff like get an instant notification in Slack or Teams the second a critical build breaks. It's a whole visibility system. Now that we've seen the 30,000-foot view, let's zoom right back in on our star player, the buildspec.yaml file. We're going to really break down its anatomy. So a build spec file is organized into a few key sections. The phases block is where the action happens. It's where you list out the actual commands you want to run. The artifact section tells CodeBuild, hey, when you're done, grab these files and folders and save them. The cache section is a really cool optimization trick. You can tell CodeBuild to save things like your downloaded dependencies so the next build doesn't have to fetch them all over again, making it way faster. And finally, env is where you can define any environment variables your build needs. And that phases section, it's broken down even further into its own little life cycle. It starts with install, which is where you'd run commands like npm install or pip install to get all your project's dependencies. Then you have pre-build for any last-minute setup. The build phase, well, that's the main event. That's where you're compiling your code. And finally, there's post-build for any finishing touches, like maybe zipping up your output before it gets uploaded as an artifact. Now let's circle back to that env section for a second because this is so important for security. You should absolutely never, ever hard-code secrets like API keys or database passwords right in your buildspec.yaml file.
Instead, you use the env section to tell CodeBuild to securely pull those values directly from services like AWS Systems Manager Parameter Store or AWS Secrets Manager when the build starts. This keeps your secrets safe and sound and completely out of your source code.
All right, now that we've mastered the blueprint, let's look at how we can use it in some more complex situations. For this last section, we'll check out two really powerful features: running builds inside your private network and, well, how to fix things when they go wrong, but on your own machine. By default, CodeBuild runs in a secure AWS environment, but it's kind of in its own bubble. It's totally isolated from your private network, your VPC. This means it can't talk to things like your internal databases. The solution is to configure CodeBuild to launch its build container inside your VPC. And this is a game changer for testing because it suddenly opens up secure access to all of your internal services. So why would you even do this? Well, think about it. What if you need to run integration tests that actually talk to a private RDS database? Or maybe you need to query an internal Elasticache cluster for some test data. By putting CodeBuild inside your VPC, you give it secure, private access to do all of that, which means you can run much more realistic and thorough tests. And finally, what about when a build fails in the cloud and the logs are not super helpful? Instead of that slow, painful cycle of pushing a fix and waiting for the build to run all over again, you can use the CodeBuild local agent. It's this awesome little tool that lets you run the exact same build environment on your own computer using Docker. It is the key to debugging and fixing your build script way, way faster. So what's the big takeaway here? CodeBuild isn't just a service. It's a way to define your entire build process as code, all captured in that one buildspec.yml file. It gives you a repeatable, version-controlled, and totally hands-off build system. So the only real question left is, now that you know the blueprint, how are you going to architect your next automated build?